Firstly, sincere apologies to the commerce friends of mine whom I forced to watch this video, because I can guarantee that after watching this video you will be resting in peace. And for the science friends of mine, please revise your physics books because this journey is going to be a hell of a ride. So, welcome to another episode of Commentator Kaku, and just as you already know, today we are going to do a scientific review of Doraemon's gadget, starting with our first gadget of today, Bamboo Copter. So as you guys already know, this Bamboo Copter was a device which acted like a helicopter and which was placed on the heads, and it would carry Nobita and his friends to various places, just like a helicopter would do. So the first step to analyzing this situation scientifically would be to draw an FBD of the system. So in this case, the Bamboo Copter would have to apply at least mg force in the upward direction so as to balance the downward mg acting on Nobita, just to keep him hovering in mid-air. But if you observe correctly, the Bamboo Copter actually fits only around the head, which means only the skin around his skull can bear the entire amount of pressure. Yes, you can calculate the pressure manually, but just to give you a real world significance, it would be much like a WWE wrestler pulling you straight from the ground only holding your hair. So yeah, that's not pleasant, right? Also, now not to mention that now the atlas bone, which is generally used to bearing the push of the head, will now have to bear the pull of the entire body below it. So yeah, you shouldn't be surprised if you get paralyzed or maybe even dead.
मरना है क्या boss? मरना तेरे को डर नहीं लगता?
Also notice the size of the blades of the Bamboo Copter. Those are really small to carry a mass of Nobita's weight. So these blades would have to be rotating at insane speeds, which is bound to create pressure waves which would definitely damage Nobita's eardrums, considering that his eardrums are very close to the Bamboo Copter and also that he's not wearing a sound muffler. Also, if you can notice, the air pushed down by the blades of the Bamboo Copter goes straight and hit his shoulders, which means there is a huge amount of inefficiency going on. That's somewhat like taking a fan and pushing air towards the sail of a ship, which ultimately does not aid in motion, and the air which only goes beside the sails aids in the motion. So I don't think this small Bamboo Copter with so much of inefficiency can sustain Nobita's weight. Okay, let me even assume that Nobita's weight is sustained and Nobita can hover in air by this Bamboo Copter. Can you explain me how Jihan is being sustained in midair? We also have something called as the second law of thermodynamics in physics, which in short means that every machine ever built should have less than 100% efficiency, which also means that you cannot create energy out of thin air. But can someone explain me where does this Bamboo Copter get so much of energy from? I have never seen it refuel even once in my life. And also, can anyone please tell me where is the fuel tank of this Bamboo Copter? Does it make the brain of yours as a fuel tank, using the power of imagination as fuel? So maybe we can say that this Bamboo Copter is not physically feasible to exist. So yeah, it fails our scientific review. But now we shall go on to our second gadget of today, which is the small light. For those who are directly born as adults, small light scales down the size of the object on which its light falls. Well, the primary implications of such a scale down are going to be serious. For example, the frequency will become so high that we would not be able to hear the person if the scale down is of a factor say 10x. Why? For that, imagine our vocal cords to be a both side open tube. Some students might question why a both side open tube, like it's open on one side and closed on the inside, right? Wrong! Well, the logic behind such a counterintuitive assumption is that for a both side open tube, you have displacement antinodes at the ends. Similar is the case for a vocal cord. This is the antinode you already know, and in case of the vocal cords, the cords themselves move, which makes them the displacement antinode. So you can actually equate both of the situations. Of course, there are much more complications. We are very much simplifying, we are oversimplifying the situation, but just to understand how the frequency is going to be multiplied, we can take the scenario and assume our vocal cord to be a both side open tube. Also, we must notice that sound tries to be in its natural frequency provided a region or a space to vibrate, and which means that we are going to have half a lambda in this scenario, and putting v is equal to f lambda, we get frequency inversely proportional to the length of the tube, which means that if you are decreasing the size of the individual by 10 times, the frequency would be going up by 10 times. And as we generally speak in the frequency range of 2000 Hz to 3000 Hz, it would be going to 20 kilohertz to 30 kilohertz, which is over our auditory range. So congratulations, you have successfully converted Doraemon into the Japanese version of Charlie Chaplin. Also, if you notice, the surface area of the body has decreased by 100 times, but the volume of the body has decreased by 1000 times, which means the surface area by volume ratio has increased by 10 times. Why is it important? Well, the heat radiated by a body is directly proportional to the surface area of the body, but the heat produced by the body is directly proportional to the number of cells, other conditions keeping constant, and the number of cells is directly proportional to the volume of the body, which means now the body will have a harder time maintaining its temperature, considering that we humans have a constant temperature in our body. But this was only about the direct implication of such a scale down. There are a whole lot of other problems with the process of scale down itself. So it is nowhere mentioned whether mass or density remains constant. So first, we'll proceed assuming mass to be constant. So continuing that trend of 10x scale down and assuming that mass is constant, the volume of the body has decreased by 1000 times, which means that the density, which is mass by volume, has increased by 1000 times. Also, notice that the cross-sectional surface area of bones would be decreasing by 100 times, which means that the breaking stress, which is the force by area, would now be increasing by 100 times, which would be well over the breaking stress of all the bones, which means congratulations, you would have many more number of bones in your body, and also that now you would be reduced to a lump of muscle crawling on the ground with broken bones. And even if I assume that the bones somehow become stronger and can support your weight, remember that the pressure under your feet would also be increasing by 100 times because the cross-sectional area has decreased by 100 times, which means that whenever you are walking now on a field, your feet would be drilled straight into the ground. But none of these things have happened in the cartoon, which means that mass remaining constant is not the case, and that density remains constant is actually what happens. Proved by contradiction, you see. So now if there's a scale down happening and density is constant, the obvious question which we need to ask is how? So the first method in which this can happen is decreasing the atomic mass, which can be done further in two methods. Number one being decreasing the number of protons in the atom. But obviously you cannot do that because if you decrease the number of protons, the very element changes. So you cannot change the number of protons. The other way in which you can decrease the atomic mass is by decreasing the number of neutrons. But if the neutron by proton ratio in an atom goes away from the ideal state of around 1.6, then the atom becomes radioactive, and that's definitely not what you want. So this entire concept of decreasing the atomic mass doesn't work. So now we come to the second part of it, which is removing the atoms completely. But the thing you see is that this selection of atoms has to be random at an atomic scale, and it should seem like as if there is a factor of reduction in a macroscopic scale. Somewhat like how you calculate the half-life in nuclear fission reactions, or maybe even how you calculate the intensity before and after light enters a polarizer. So what is this amazing piece of technology which can create randomness just at par with other natural activities, considering that it should be theoretically impossible to compute out randomness? The reason why I say that it's impossible to compute randomness is because I put it in this way. For making randomness possible, you have two options. Number one, go through a very complex mechanism and send out numbers such that it seems random to the user. But remember, there is a programmer who wrote the program for this very random function, which means that if you know the program, if you know the algorithm, and if you know the first few values, you can predict the next value with 100% accuracy, which means the very randomness of it is gone. The other way which remains is that you can observe natural noises. For example, you can observe the audio noise in the area and then you can say that it's random. Or maybe you can even observe the airflow in a very turbulent system and call it random. But if you knew the very exact forces which were acting on the air molecules, if you knew that what are the velocities of every molecule and what are the positions of every molecule, you should be able to calculate out every possible configuration of the entire system for the next few seconds with 100% accuracy, which means the randomness inside it is gone. It will require some huge computational power and a huge amount of precision, but that does not mean that it's impossible to achieve. It's just that we do not have enough computing power to achieve that, but it is possible to achieve, which means our computers are actually generating things which we can predict, which takes away the randomness from it, which makes it pseudo-random. And that's the thing which I am saying. We right now do not have any way of creating something which is random. So what is this amazing piece of technology which we have seen in Doraemon, which completely breaks the barrier and makes it possible for randomness to exist? So yes, this small light also fails our scientific reviews, just as the bamboo copter did. So these inventions are absolutely not realistic and do not fit our scientific textbooks. But wait a minute, these are cartoons, not science textbooks. Of course they are going to be improbable and impossible in the real world. As long as it could entertain us when we were children and make our childhood better, there's absolutely no problem with it being scientifically inaccurate. Tell me in the comments what are the other Doraemon's gadgets I should scientifically review, and also share this video with your friends if you think this video was good enough. And also if you think that your syllabus got revised, considering that you are preparing for a competitive exam very soon. Also do subscribe if you think that this video has earned it, and hit the bell icon so that you can be notified when we are going live. And as always, keep commenting.